Okay. Good evening, everyone. How you doing? Thank you for joining us tonight.
Good evening.
And we have with us John Curry, and we have Gerald McKeegan, and Rick Taft has joined us tonight. And I want to mention Rick because he has allowed us to use his brand new Canon RA astronomical. It's not a DSLR. It's the next generation of Canon cameras. It doesn't have a flip mirror in it. The whole thing is digital, but it's designed for astronomy applications, and we're trying it out for tonight's program. And so far, so good. So thank you, Rick. We're sitting here at the Basin Science Center, and I am in front of Nellie, our 36-inch research reflecting telescope. And Rick, who is also our lighting director tonight, is going to shine a light on it because we could barely see anything here. And we can't even see Rick's light. Here, let's try it this way. There we go. Now you can see it. Yeah. So Nellie is our largest instrument here at Chabot, and it's a classical Cassegrain telescope. We also have two historical refractors that were built around the turn of the century, late 1800s, early 1900s. One is an 8-inch Alvin Clark refractor telescope, and the other is a 20-inch Brashear refractor telescope. And once we open up to the public again, we invite you all to come and take a look through those beautiful instruments. Tonight's a special night. Gerald, it's International
Observe the Moon Night.
Yeah, and I have to admit that I told my friends the wrong thing. I told them it was International Howl at the Moon Night, and I want to apologize to their neighbors, and because that was a terrible mistake on my part. So what we're going to do tonight is give you a tour of the visible part of the moon tonight, and it's not a full moon, but that's to everyone's benefit, because when it's not a full moon, we're able to see shadows and the relief of the mountain ranges and all kinds of other interesting things that we can't see during a full moon. So Gerald, who is an expert on the moon, he has memorized the name of every single crater on the moon. And in any case, Gerald is going to be doing most of the talking, which will probably make most of you happy because I'll be quiet here in the corner after I'm done with the introductions. So, I'm sorry, go ahead.
And if you believe that I know all the names of all the craters on the moon, I've got a fine piece of beachfront property in Nevada to sell you. So
I also have to apologize for Gerald. He's very grainy tonight.
Yeah.
He woke up feeling very grainy, and he brought all that grain with him in his laptop, and we haven't figured out why this is, but you'll just have to kind of put up with it. So I'm going to get started by sharing the screen with our camera here. So bear with me for a moment.
Well, hang on. I want to show the full.
Oh yeah, that's right. I'm sorry about that. Yeah, you go ahead.
So let me share my screen here for just a second, if I can. All right, everybody see that?
Yeah.
All right. So this is the full disk of the moon. It's the kind of image you might see if you looked at the moon with a pair of binoculars. A lot of times, if you're watching some TV show, one of the many reality shows, and they want to show a close up of the moon, it'll be something like this when they zoom in with the TV camera. But this is just to kind of get you oriented to the moon and what gross features you see on the moon. You see some dark areas and you see some light areas. The dark areas are primarily basins and low level areas, primarily the basins of old large impact craters, and they have filled with lava. So these impacts occurred a long time ago, like 4 billion years ago. and they were very large impacts. This was at a time when the solar system was still forming, and there were a lot of big objects flying around, and they would hit the moon and produce these big impact craters. And at that time, the moon still had a molten interior. And so you get these big impact craters, which would crack the crust all the way down to the molten interior. And then the lava would ooze up through the cracks and spill out onto the surface and would fill these big impact basins. And that's where you get the dark color from. And as you'll see in a little while, when you zoom in on those areas, they're much smoother. They don't have as many craters, and that's because the lava filling those basins occurred after most of the craters were formed on the moon. So that's kind of a, why we have the dark areas. The dark areas are the features when we talk about the man in the moon, or the rabbit in the moon, or the old lady in the moon. Those different cultures have different sayings about what they see when they look at the moon. And it's those dark features that produce most of whatever it is you see. You also see some light areas, and those tend to be older regions of the moon, often higher in elevation. So we call them the highlands, especially in the southern part of the moon, down low. Those are the highland areas. And this is the older part of the moon. It's representative of the original crust. There's a mineral called anorthosite that's very common in those regions. And it gives it that brighter color. Now, when you look at the moon with your eye, just, when you go outside and look at the moon, it looks pretty white. But in reality, the moon is very dark. If you go up to the moon, especially in the mare, the seas, the ground is very dark. It's almost charcoal black. But with the bright sun shining on it with no atmosphere, what small amount of light that does get reflected makes the moon look pretty bright. So keep that in mind, especially when you see astronauts walking around on the moon. You see the lunar dust get on their spacesuits, and that dust is really dark. So with that, I think what we're going to do, we're going to zoom in. Now tonight, we don't have a full moon like this. What we have is what's called a waxing gibbous moon. So we're about 8 days from new moon, 7 days, I think, or 8 days from new moon.
Full moon.
So from full moon, from new moon. No, 7 days from new moon.
Oh, from new moon. Got it. Sorry.
Probably 3 or 4 days yet before full moon. And so what you're going to see is that the left side of the moon is going to be dark and the right side is going to be light. So, Richard, I'll stop sharing my screen here. And if you want to share yours, we're going to zoom in on this. We'll start with the northern part of the moon here. So we'll just give you a guide.
Okay. Get this here. There we go.
All right. So let's see, I'm going to kind of move the camera over a little bit here. Oops, wrong direction. And we'll go north a little bit. And it looks like we're a little out of focus. So let me see if I can improve that. Whoops.
Try the other way.
Wrong direction, right? That's a little bit better.
Oh, there we go. That's nice.
There we go. All right.
Good job.
Okay, so we're looking at the northern part of the moon. That big round crater with the smooth floor, that's called Plato. And Plato is an impact that actually occurred after most of these larger impacts occurred, but it did fill with lava the same way as the large sea that you see to the south. And we'll talk about that sea in a minute here. If you look just north of Plato, you see a large smooth area that's called Mare Frigoris. Mare means sea. And so that's the Sea of Frigoris. I forget what Frigoris means, but that's Mare Frigoris. If you look down and to the right, you'll see a couple of craters. Rich, you may have to do the pointing here. So
Yeah.
down and to the right, there's two craters. A little right, up.
Oops. Right there.
Yeah, I can't see your cursor.
Yeah, unfortunately the cursor does not
Yeah. All right. Okay. So you see two craters. The upper one
sorry.
is a little bit bigger than the lower one. Those two craters are Aristoteles and Eudoxus. And then between those two craters and Plato, you see kind of a range of mountains. That range is called the Alps. And if you look very carefully, you'll see a kind of a straight trench or valley or something like that right across there. Um, that is a graben. It's an area where the mountains have slumped down in a crack. And the reason for that is that large smooth area to the left is called Mare Imbrium. Mare Imbrium is the largest impact basin on the moon. It's very large. I'll move it down here a little bit so you can get an idea what I'm talking about. So this large smooth area that you see below Plato is the impact basin called Mare Imbrium.
It's okay.
And it has filled with lava, so it has that dark coloring. And you notice there are very few craters there, which tells us that the lava flow is a lot younger than the moon is. The moon is somewhere around 4.5 million or billion years old, 4.5 billion years old. And there's some debate about the exact age. There's a recent paper that came out that suggests it's a little bit younger, like about 100 million years younger than what we previously thought. That's typical in astronomy. As we get more data, we adjust our thinking about a lot of things. So looks now like maybe instead of being 4.5 billion years old, it might be 4.4 billion years old. When it first formed, it formed because of an impact with the Earth. There was an object floating around, a small planet about the size of Mars, that impacted the Earth. And that impact threw material out into space, which then initially formed a torus, like a donut around the Earth of rocks and material that eventually coalesced to form what we see now as the moon. And initially, the moon was much closer to the Earth. Over the centuries and eons, it has moved away, and it continues to move away. The moon is moving away from us about 1 inch per year. And that's because of an gravitational interaction with the tides on the Earth. So anyway, the impact that produced the Imbrium Basin happened very early in the moon's history. You then had over several million years this lava flowing up and filling the basin, and then you had other craters formed later on. But early in the solar system's history, there was a lot of asteroids and comets flying around, and many of the craters, in fact, most of the craters that you see on the moon are extremely old, on the order of several billion years old. The moon has no atmosphere, has no waters or streams or anything like that to erode the surface. There's no plant life or animal life. So there's no weather. So you punch a hole in the moon, that hole stays there for billions of years. Some of you may have seen the footprints left on the moon by the astronauts. Those footprints will still be there 1 million years from now. So things kind of stay pretty much the way they are for a long time on the moon.
Hey, Gerald, may I share something real quick?
Sure.
All right, you were talking about the crater Plato.
Oh, yeah, that's right.
And let me share this image I've got. So there's craters in craters.
Yes. Yeah.
So Plato, it looks like, in the live view we were just looking at, it looked like a very smooth black surface. but in fact, it has a whole series of smaller impact craters inside of it. And this is a picture of 18 cataloged what's called craterlets on the floor of the Plato crater that we were looking at. And I thought it might be interesting seeing that. And this also gives you a good example of why viewing the moon during one of its phases is always superior to looking at a full moon. You'll notice that each of these little craterlets has the sun hitting on the left-hand side with the right-hand side in shadow. So if it had been a full moon, it would be much less interesting to look at, and it wouldn't be quite as obvious. Anyway, that was that.
Yeah. The sun is actually to the right, and that produces the crater or the shadows on the right side of the craters. So, all right, let's get back to the live view again.
And there's Plato right here.
Right.
Screen.
All right. Okay. So continuing our tour, we were talking about Mare Imbrium. As we move south a little bit, you see some more craters here. There's the big one is, you see 3 craters there with smooth floors. The big one is called Archimedes. There's one off to the left of Archimedes called Timocharus. And let me continue on down. And just to the right of Archimedes, you see another mountain range. And that one is called the Caucasus. So the one north up near Plato is called the Alpines. The one just to the right of Archimedes, that's called the Caucasus. And then when we get a little bit lower, we're going to see the Aponines. And you may recognize these names because these are names of mountain ranges on the Earth. And so these mountain ranges on the moon have been named after mountain ranges on the Earth. So I'm going to continue on down here. We're now at the bottom end of the Imbrium Basin, that long arcing mountain range, that's the Aponines. And you see some craters to the left here, and I'm going to move over a little bit because these are really interesting craters. All right. So you see a really big one right to the left near the Terminator. The Terminator is the boundary between the part of the moon that's lit and the part of the moon that's not lit. That big crater there is called Copernicus. And if you look carefully, you can see stuff has splashed out of Copernicus onto the basin floor of Mare Imbrium and the area around Copernicus. Copernicus was a pretty powerful impact. And so material was thrown up out of the crater and it splashed out. It was ejected out of the crater and it splashed out onto the ground. When these impacts occur, it's not unusual for the crust of the moon to actually be liquefied because there's so much energy involved, and it can splash out and then it hits the ground and solidifies again. If you look at the center of Copernicus, a couple of things you'll notice. You'll see some central peaks. And if you look carefully, you'll see some terracing around the edge. The central peak is called a rebound peak. And so what happens is an asteroid comes and it hits the surface of the moon. It plows its way down into the ground, compressing the ground underneath the crater, and at the same time throwing stuff out to the side and up and forming the rim of the crater. The surface that's pushed down by the initial impact, once the energy is depleted, that compressed part at the center of the crater rebounds back up. And at the same time, you get material from the rim sliding back down into the middle of the bowl of the crater. And those two forces combine to produce that peak, which is called a rebound peak. And it's just material that basically has sloshed back up into the center and forms a peak. The terracing is also indicative of the slumping that I was talking about, the slumping of the crater edges. You often will see that terracing. And now these effects happen primarily with the bigger impact craters, and they're especially noticeable with younger impact craters because the features have not worn down because of all the other impacts that happen afterwards. So young craters, we see a lot more detail like this than we do with older craters. Let's see, the crater to the right of Copernicus, smaller crater, that is the crater Eratosthenes. It's a crater that's named after a Greek philosopher who was the first that we know of to attempt to measure the circumference of the Earth. And this was back around 500 BC, maybe a little bit, or maybe 300 BC, somewhere around there. And Eratosthenes was down in Alexandria, in not Virginia,
Alexandria, Virginia. Yeah,
in Egypt.
That's where his summer house was.
Yeah, okay. in Egypt, and he learned that there was a small town along the Nile, quite a ways south of Alexandria, and in that small town there was a well, and once each year, probably more like twice each year, but only on one day, the sun was in such a position that it shone straight down the well. So he got the idea that if he set up a pole in Alexandria, which was several hundred miles north of this town, the town was called Syene. If he set up a pole, a vertical pole in Alexandria, because of the distance between the two, even though there was no shadow in the well, there would be a shadow of the pole. And the length of the shadow of the pole would give him an angle. And from that, he could calculate the circumference of the Earth. Now, his measurements were crude, so his number wasn't real exact, but it was a very good approximation. And his methodology was scientifically correct. So, given the crude instruments that he had in that period, he still came up with a pretty good number for the circumference of the Earth. So we named a crater after him. So
when were these crater names assigned?
Actually, over several hundred years, different people have mapped the moon at different times. There's a guy named Grimaldi that did it, and there's two or three others. I forget the names of all these different people that did it. And they didn't all name the craters the same. So
Right.
there has been, there is now an organization called the International Astronomical Union, and they're the ones who sort of settle on what the name of a crater will be. So, there have been different people who have named craters at different times. The craters on the side of the moon that faces us, a lot of them are named after famous people in Greek history and in the history of lunar research. A lot of the craters on the far side of the moon are named after Russian scientists, because the Russians were the first one to photograph the far side of the moon back in the 1960s. Okay, so we got Copernicus, we've got Eratosthenes. Thank you. Going a little bit farther south here, let me move the camera. Got a couple of other craters here. Reinhold, I see there. This is,
there you go.
This region that we're looking at now is called,
yeah.
Mare Cognitum. And we'll go a little bit farther south even. We're getting towards the lower half of the moon. There's a feature, I want to try to get it. It's over to the right a little bit, except I'm going the wrong way. We call it the Snowman. And we're seeing part of it right here.
There it is.
Yeah, so this is called the Snowman right there.
These two here, right?
Those three actually. So
Oh,
the
got
big
it.
one up at the top, that's Ptolemaeus.
Yeah.
The one down and slightly to the left, that is Alphonsus, and then the one just below that is Arzachel. All right, and we often call these three the snowman. It's like an inverted snowman. And then there's another feature that I want to try to see if I can see. I'm not sure if we're going to be able to see it very well or not. I don't see it. There's a feature that's just to the left of Alphonsus, and it's not showing up very well in this image here. It's called the straight wall, and it's basically a crack in the surface where one side
let me play with
down.
this for a second. Let me see whether we can make
All right.
this appear. Can you move it up a little bit so it's more centered?
Okay.
Where the straight wall will be. Okay, so the straight wall would appear like right around here.
No, more to the left.
Oh,
more to
okay.
the left.
Tell me. Oh, I see. It's going to be right here. Yeah. Okay. Let me try.
Yeah, it's a hard feature to see with this.
It is,
with
but
this.
it's right here.
Yeah, the light is not quite right. If we
Yeah,
look tomorrow night, would actually
tomorrow night
right.
would be better, probably. Yeah.
Yeah. So
I'm just trying to see if I could.
Yeah.
You could just barely make it out, like right here.
It's
Anyway.
called a straight wall. It looks like a straight line, and it's actually where one side of it has slumped down, and it's formed this big long cliff. And you can see it when the light is just right. You can see it in the telescope, and it's pretty easy to see. And it's called the straight wall. So let's continue on south here. All right. So you're going to notice a lot of long streaks in this image here. And they come from a crater which is right at the, it's just down near the bottom. It's the one with the central peak, close to the Terminator. Right there. There you go. All right. So that's the crater Tycho. And when you look at the moon with a pair of binoculars or a smaller telescope, you'll see what looks like a bright spot on the southern part of the moon, and you'll see these long white streaks extending away from it. And that crater is called Tycho, and it's actually a relatively young crater, only about 100 million years old. And it has ejected a whole bunch of material that has extended far away, more than 1,000 miles from the crater. And when you look, like I said, with a pair of binoculars or something, you can actually see these long streaks, and it's just ejecta that was thrown out of that crater and extended far out in all directions. It's pretty spectacular when the light is right to see those ejecta rays that are extending away from Tycho. So going down a little farther south, we're getting into the southern highlands here. There is one other feature that I want to see, and it's right at the Terminator. And this is actually a really good light for this. Straight down below Tycho is the crater Clavius right there. And Clavius has some much younger craters inside of it that form kind of an arc. And right now, because of the way the moon is tilted, it's tilted so that Clavius is a little bit of an angle to us. Sometimes it tilts a little bit the other way, and we see it straight on or almost straight on. And it's really a neat feature to look at with a telescope.
And Clavius, of course, was popularized by which famous science fiction movie?
Well, Clavius and Tycho, the Tycho anomaly.
Yeah.
Yeah.
2001: A Space Odyssey.
Yeah. So yeah, in the movie 2001, they had a Basin Clavius, and then the Tycho anomaly was that obelisk that they found in the crater Tycho. So now you know where they were talking about. All right. So what we're going to do, we're looking at the southern part of the moon right now. I can kind of go all the way down, and you see the bottom edge of the moon. And we're going to go over to the right, I think, if I push the right buttons. And
There's a interesting discussion going on Facebook right now. I'm kind of watching this as you're talking, where there's a debate that has sprung up here on whether or not the moon might be hollow. And well,
No.
we want to at least consider all the possibilities here. It's probably unlikely. I mean, there's a lot of gravitational pressure, and to maintain a hollow structure would be difficult, and there'd be no reason that its original molten composition would have left behind a hollow structure, and there isn't any geological process that would have occurred after the moon cooled that would have created such a structure. But if it was hollow, that would be pretty neat. But it's probably not.
Yeah. Yeah, the Klingons could have a base in the hollow moon.
Yeah, right. Yeah.
So Richard, if you can change your exposure a bit, we're going to be looking at the brighter part of the moon.
Oh yeah,
so
that is
maybe
very bright. Hold on, let me take a look at that here.
So bear with us, folks, while we do a little adjustment.
Yeah, we got too much contrast here, and the brightness.
Oh, there you go. All right. Yeah.
That looks good. Yeah, there we go. That's much better.
All right. We're chasing the focus a little bit here. We got some thin clouds going on. So, I apologize. We don't have as sharp an image as we'd like it to be. We'll see if we can sharpen it up here a little bit. It looks a little bit better. All right. So the area we're looking at now is called the Southern Highlands, and this is older terrain, much more heavily cratered, smaller craters, and this is the original crust of the moon. And you see, you can tell the younger craters because they're brighter in color. And we'll move on up here to the north a little bit. And we'll move over a little bit to the all right, here we go. Okay, so the round area, that's called Mare Nectaris, the Sea of Nectar. And right at the top edge of Mare Nectaris, let me see if I can move this a little bit farther north here. It's not very clear because you got sunlight shining directly into it, but there is a crater, and you can see the central peak of that crater. Richard, if you can kind of.
Are you talking about this one right here, right? Or is this one?
Right there. That's it. That's
got it.
That's it. Okay, so that crater is called Theophilus. When the light is right, it's a pretty dramatic thing, and it has a very big central peak in it. When the sun is directly overhead, you get no shadows and you can barely tell that there's a crater there at all. But when the sun is at the right angle, it's real obvious that there's a crater there. So that's called Theophilus. And then you got Mare Nectaris, which is a large dark area. That's another one of the seas. And now we're going to go north and we're going to get into some familiar territory here. All right, so let's see. I'm going to, wrong direction again. Okay, the large dark area that you see there, that's called Fecunditatis, Mare Fecunditatis. Let's see, we'll continue on up and get to a mare that many of you may recognize. Okay, so the circular one on the right, the circular mare on the right is called Mare Crisium. That dark one on the left, that is the Sea of Tranquility, Mare Tranquility. The Apollo 11 moon site is down in the south western part of it, which is down and to the left, right in that region right there. That's where the first Apollo landing occurred. Now you notice that Mare Tranquility, or Tranquillitatis, or the Sea of Tranquility, is much darker than Crisium. In fact, out of all the basins, it looks like it's the darkest one. And that's because the lava that filled Mare Tranquillitatis is a different type of lava, and it has more titanium in it. And titanium gives it that darker color. And in fact, if we were to take a very careful color photo of the moon, you would see that dark area actually has a bluish tint, and that's because of all the titanium in it. Now, in between Crisium and Tranquility, you see a bright crater, which tells you it's a young crater, and it's got an unusual ejecta pattern around it. That is called Proclus. And Proclus was caused by an asteroid hitting the moon at a very shallow angle. And because it was such a shallow angle, even though it formed a round crater, you get round craters even when you hit the moon at a shallow angle. But because of the shallow angle, the ejecta all sprayed out, if you will, forward and out to the sides, and kind of like a butterfly pattern. So you get no ejecta in the direction from which the asteroid came. You get a lot of ejecta out to the either side, and then some ejecta going straight in the direction that the asteroid was flying. So this is a really interesting study in the ejecta pattern dependent on the angle of the impact. All right, we'll go a little farther north here. How are we doing on time?
It's 9:30.
Okay. All
Actually,
right.
9:40. Yeah.
Okay, so here's another basin. North of Tranquility is the Sea of Serenity. So that's that region right there. Off to the right, near the top, again, it's a crater that you can just barely make out. A little bit lower, and to the left.
Oh, this one.
That guy right there, that's Poseidonous. And again, this is a crater. If the light was right, it would be very distinct. You would be able to see it very easily. But because the sun is shining almost directly onto it, we see no shadows, and so it's barely noticeable. Going a little bit farther north from there, just out of the frame, let me go a little bit higher. And there's a couple of craters I wanted to point out. A little bit higher here. Okay, so just up to the right, you see a round, kind of smooth floored crater.
Are you talking about
No, up, farther, right there, right there.
that
All right,
one?
all
All
right,
right.
that's Adamion. Okay, and then coming down and to the left there are two craters, which again, because those two right there, the left one is called Hercules, the right one is called Atlas. And again, because of the light, you don't see much there, but those craters are actually real distinctive when the light is just right on them. And we're almost back up to the north again. So
Yeah, when you get back up to the north, my audio was cut out during the Plato craterlet thing, so I might show that again
okay.
because
All right. Well,
people didn't hear anything I said,
oh,
which it may be better for them
yeah,
anyway.
yeah.
But
Is that a bad thing or a good thing?
I don't
Okay,
know.
you're gonna have to change the
I'm gonna
exposure
change it.
again.
Yeah, I'm gonna go do that right now, and it'll bring it back to 100th of a second. There we
There you
go.
go. There you go.
And we'll go back here. All right. So that's the crater Plato. And what I was showing people earlier, I'm going to hit share screen here. And is that it's craters inside craters. And when we're mapping the features of the moon, it's not always just the really large scale features, but there's a lot of interest in the much smaller scale features. So this is the crater Plato that you saw earlier in the upper left corner of the live image. And it's 18 of what are called craterlets. And these are craters that were formed after the impact that created Plato in the first place. And it gives you kind of an idea of how you could tell the illumination just by looking at those craterlets. The sun is off to the right-hand side, illuminating the left-hand side of each of those craterlets and leaving a shadow on the right-hand side. And it's just interesting to see how many additional impacts there are within any of these large impact craters.
Right, right. And as you can see, astronomers have a lot of imagination in naming little craters.
Yes. Yeah.
Little crater A, little crater B.
That's right. Well, they did say East Wall Pit.
Yeah,
That
well, there
was
you go.
that was at least a little more imaginative.
Yeah.
All right, I'm going to stop the share on this and go back to our
Okay.
live view.
Okay. So if we haven't made it clear yet, the craters we see on the moon, almost all of them are impact craters, asteroids and comets hitting the moon over the course of billions of years, producing all these craters. However, there are also some volcanic craters on the moon. The moon is no longer volcanically active, but there have been volcanoes in the past. But the craters from volcanoes are very small compared to the craters you see like Plato and the craters around it. The volcanic calderas or craters are much smaller. 150 years ago, there was a lot of debate about whether the craters we saw on the moon were caused by volcanoes or by impacts. But today we know that the vast majority of those craters are caused by impacts by comets and asteroids.
How frequently are we getting new impacts on the moon?
Probably a couple of times a month. But most of them are extremely small. There are a lot of rocks flying around in space that are only the size of your fist or smaller because the moon has no atmosphere. They actually impact the surface of the moon. We get rocks that size and smaller hitting the Earth as well. But because we have an atmosphere, they burn up in our upper atmosphere, and you see them as shooting stars. Now, you might ask yourself, well, wait a minute, why aren't there impact craters on the Earth? Some people even think that, the moon, because it's got so many impact craters on it, it must be protecting the Earth from impacts. And that's not true. In reality, the Earth gets hit about 16 times more often than the moon does. But the Earth has weather, we have oceans, we have vegetation, we have plate tectonics, we have all these different forces that are constantly reshaping the surface of the Earth and basically burying the craters. There are craters on the Earth. There are about 180 readily identifiable craters that we know of, and probably over 1,000 that, by studying carefully features and the terrain and the geology, we can tell that there was once a crater there. So the craters do exist. Some of them you can actually go visit. Probably the most famous one here in the United States is Meteor Crater. Technically, it's called Barringer Meteor Crater. It's in Arizona, about 30 miles east of Flagstaff. And it's got a visitor center. You can go there and learn a lot about impacts. You can take a walking tour around part of the crater. You cannot go down into the crater, but you can walk around the rim. Meteor Crater is about 3/4 of a mile in diameter, a little over 1 kilometer in diameter, and it's about 600 feet deep. And it was caused by an iron meteor, iron asteroid that became a meteor when it entered the atmosphere. It hit the Earth about 50,000 years ago and produced this big crater. And even that crater had a lot of debate about whether it was volcanic or an impact crater. If you've ever visited the Flagstaff area, there are a lot of actual volcanoes and volcanic craters around Flagstaff. So, 150 years ago, the assumption was Meteor Crater was just another volcanic crater. But a guy named Dan Barringer in the late 19th century, he was convinced that it was an impact crater. And so he actually bought the crater and started digging down in the center of the crater looking for the meteor that he was certain was under the ground in the center of the crater. And he never found it. But his family continued to own the crater. They still own it today. And eventually, researchers were able to find the meteor, not straight down in the center, but off to one side. Turns out that the asteroid that caused that crater hit coming down at an angle from the north. And so the remnant of the asteroid was found not directly below it, but actually outside of the rim of the crater on the south side of the crater, which meant it came from the north.
So it bounced.
No, it didn't bounce. It buried itself in the ground, but it came
I see.
in at an angle so that if you dug straight down in the center of the crater, you wouldn't find it.
I
But
see.
you went just south of the rim and then dug straight down, you found it. So they actually have chunks of the iron meteorite on display there in the visitor center at Meteor Crater. It's a great visit. It's a great way to learn a lot about impacts and about geology. One of the interesting things is the area where it hit, it was a big flat desert. And if you were to dig down in the desert, you'd find layers representing different eras in the Earth's geological history. But if you get close to the crater and you do that, all the layers are in the wrong direction. They're actually upside down. And the reason for that is when this meteor hit the ground, it penetrated into the ground and then explosively produced the crater, which caused the ground around the crater to flip up and flip over upside down. So as you dig, if you go like, 50 feet outside the rim and start digging it down, all the layers are in the wrong direction or in the opposite direction. And then eventually you get down to where the original surface was, and then the layers are in the right order again. So it's a
That's really interesting.
cool effect. So
Give us a sense of the diameter of the Plato crater that's on the screen right now.
I would guess
Just a rule of thumb,
somewhere
I guess.
around 120, 150 miles or so. It's pretty big.
Okay. So those craterlets are just anywhere from 5 to 10 miles
Yeah, much smaller
in diameter.
Yeah. And when you show that picture, actually a lot of amateur astronomers, it's kind of a fun thing to, take a picture, get your telescope and put a camera on it and get it set for very high magnification and wait for moments of clarity and take pictures and try to see how many of those little craters you can see. So lots of fun. So that's pretty much it for the tour. However, you may have looked at all this and said, gee, I wish I could, do a little of my own touring of the moon with a small telescope. And you actually can do that because there are a number of books out there that give you a lot more detail about the geography and the names of craters and so on. And I think, Richard, you've got...
I was going to mention a few. I didn't bring any with me tonight. I actually brought one with me, but it's buried in the bag. I wanted to give recognition to Bob Garfinkel, who is a East Bay Astronomical Society member and has long been involved with the Chabot Basin Science Center. He has produced a 3-volume set called Luna Cognita, and it's probably one of the most comprehensive atlases and descriptions of the moon that's been produced ever. It's really an amazing work. He's spent a good part of his life producing it, and it's something that's available on Amazon if you're interested in something that you could spend years going through and reading. It also has a lot of the descriptive information about each of the craters on the moon, what we were talking about, and many more. Geology, naming history, and anything else that's interesting about them. It's very comprehensive atlas. For something that's a little more portable, my personal favorite is an atlas of the moon by a lunar geologist named Rukl, R-U-K-L, and the Rukl atlas. He's a Russian lunar geologist, and it was reprinted around 2005 by the folks at Astronomy magazine, and I'm pretty sure it was Astronomy, not Sky and Telescope, but it was one of those two, and now it's out of print again, but used copies are available. I've seen them on Abe Books and Amazon for a reasonable amount. Before the reprint, they were very rare, and they were selling for like $400 for a copy of these atlases, which is pretty crazy. But now they're down to a reasonable price on the used market. And then the last one, oh, that's a really interesting feature. I'm sorry, you're looking at a really cool feature, which is this, the line, the ridge right here. You see that?
Yeah, that's the Graben.
Yeah, the Graben. Yeah. I didn't really notice it so clearly earlier, so it really seems to have stand out now. But anyway, the last one, which is also hard to find but is a good atlas, is another book put out by an East Bay Astronomical Society member, which was John Westfall's Atlas of the Lunar Terminator. And that's also become kind of hard to find, but it's another beautiful book, complete with photographs. I had a funny story about that when I was at an event, I think it was about 15, 20 years ago, and it was a star party, and a bunch of amateur astronomers sitting around were talking about what's the best atlas to get. And I mentioned the atlas of the lunar Terminator, and somebody stood up and he says, "I don't want an atlas of the lunar Terminator. I want the whole moon." And of course, I was just joking. The Terminator, of course, is something that changes on a daily basis, and it's just the area where the illumination of the sun turns into shadow. So those are some ideas, and there are other lunar atlases out there for less money than the ones I was talking about, but those are interesting ones to look at, especially if you're a collector.
All right. Well, do we have any questions coming across on Facebook that we need to answer?
I think John got kicked off of Facebook. He's sitting here. He was having Facebook problems tonight. Sorry about that. Yeah, we actually had a lot of technical problems tonight. Part of it is that Facebook has changed the interface on how to link Zoom to Facebook streaming. So we were struggling with that, and we've had some audio and visual issues tonight as well. Alan, thank you, Alan. There's an app for Apple devices, iOS devices, called Moon Globe, and it's a 3D map of the moon, and it's free. So you don't have to spend $50 on a out of print copy of Rukel. You can just get that. It's called Moon Globe. Oh, that's a good question from Virginia. Why are younger craters brighter?
Because they kick up the underlying crustal material, and it takes time for that material to darken. So minerals like anorthosite is actually pretty bright in color, but once it's turned up and exposed to the sunlight, it goes through a weathering process. We call it space weathering, and it causes the rock to darken. So initially you get this very bright material, but then over time, because of space weathering, it gets darker and darker.
Great. Thanks. Sabrina mentioned that NASA has some these are excellent sites. They have something called Trek, TREK, .nasa.gov, G-O-V, and /moon. And they actually have this same interface for planetary and lunar bodies throughout the solar system. And it's a way to explore the photographic record from various probes that have visited the moon and other bodies in the solar system. And you could look at the surface features in all these different spectra in order to understand the geology as deeply as you'd like to. But that's a great resource. I remember when they finally turned on that site, it was just a few years ago, and it's really one of the best tools available for this type of thing. Yep. So that's trek.nasa.gov.
There's also some software you can get for your laptops or your desktop computer called Virtual Moon Atlas, and it lets you explore the moon. It will show you what the moon looks like, where the Terminator will be at any given time. You can click on the craters, and it gives you a whole lot of information about the craters. In fact, I just used it to look up the size of Plato, and I was off by a little bit. Plato is about 101 kilometers in diameter, not miles. So that makes it a little over about 63 miles in diameter. So I was off
a little bit smaller, but yeah, it's interesting. Zelin was asking about the gray bond feature, which is, I'll put my cursor on it again. Here's Plato. Here's some jumbly mountains here, and then those are
the Aponines.
And then there's it's almost like a canyon. That's a straight line going right through here. And what do we know about the formation of that? Do we know anything?
It's actually there are a number of cracks extending away from the Imbrium Basin this particular crack runs right through the what's called the Alps on the moon. It's named after the Alps on Earth, and this crack runs right straight through it, and it has caused all of the terrain to have slumped down. We actually see grabens on the Earth as well, so it's a familiar feature. And it's just, when you see it close up, it looks like a straight canyon that runs right through the middle of that mountain range. It's a cool feature, and it's just ground that has slumped down and along the edges of this crack that propagated out from the Imbrium impact basin.
Cool. My apologies to Pallavi. We are not able to zoom out to look at the entire moon. It is the nature of this particular telescope that it magnifies everything to a large degree, and this is as zoomed out as we can get. We would have to hook it up to a smaller telescope or just aim a camera at the sky as it is. See if there's anything
Yeah,
else
most
here.
people want to zoom in. He wants to zoom out, so.
Oh, there we go. So Margot said that her daughter says she sees the shape of a banana on the moon. This is not the first time I have heard that story. My wife,
Okay.
my wife took an astronomy course at Cal State several years ago, and there were some students in the hallway insisting that the moon looked like a banana, and she came home and told me about that, and to get my reaction.
Hey, Richard.
Right.
Richard, if you let me share my screen here.
Oh, sure. Go ahead. There's nothing
right.
blocking you. You should just be able to do it.
All right. So yes. All right. So there is a view of the full disk of the moon.
Ah, there you go.
This is actually taken with a different telescope at another time, but it turns out it's very close to the same phase. This is about maybe a day earlier in terms of the phase. So you don't see, well, you see Plato, but it's just
barely
right there.
Yeah.
So not even a whole day difference here with the Terminator position. But, this is the Imbrium Basin right here. This is Serenity. This is Tranquility. There's Chrysium over here. This is Copernicus, the crater I was talking about a while ago. Down here, you see Tycho, and you can see all these rays extending out from Tycho. So there you got the full picture of the full disk of the moon. But we can't take this kind of a picture with this telescope because it's just too powerful.
So everybody is sharing their stories about being at some university where their classmates are talking about the moon looking like a banana. So I guess we're not alone. Yeah, that's pretty funny.
So yeah.
Yeah, I do. The man of the moon, the rabbit of the moon, and
Okay, what's going on here? Why am I not grainy anymore?
Oh, are you not grainy anymore?
I'm
You're not.
grainy.
Oh, welcome back. Welcome to the real world, Gerald. We don't know why that happened, but yeah, you do look a lot better now.
Well, thank you.
Yeah. All right. So I don't know. Are we done for the
Well, I think it's a little after 10 o'clock. So
all right. Well,
I want to thank everybody. I want to remind you that we're going to do this again next week on Saturday night starting at 9 o'clock. And we will then be looking at some other things like planets and maybe some deep sky objects like nebulae or galaxies or star clusters or whatever else we can find out there in the sky. All we got to do is keep our fingers crossed that the weather continues to cooperate with us. Also, I want to remind everybody, if you haven't already, click that donate button on Facebook, or you can go to the Chabot website, chabotspace.org, and there's a donate button up at the top of the page on our website. And please help us out. The Chabot Space and Science Center right now is closed to the public because of the pandemic, but we are continuing to do programming, like the virtual programming, and we do some other things. And we are making preparations for reopening next year to the public once the pandemic is over with. So please help us out by continuing to donate. All right.
All right, thanks. Thanks, everyone.
All right. Everybody have a good evening.